assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this example, given that we know the induced current in a conductive wire loop here is clockwise, and also given that the magnetic field strength is increasing over time, we want to determine what the direction of the original magnetic field was, given this induced current. All right, so the first thing to realize here is that given our induced current, we can determine the direction of the field that comes from the induced current. So if we curl our fingers in the direction of our current, for our right hand, our thumb should point into the page. So by the right hand rule, we know that the induced magnetic field points into the page. So B induced is into page, which I'll denote with just like a red X. Okay, so now let's look at the different scenarios for the original magnetic field that this loop is in. And given all the information we have, that is the direction of our induced magnetic field and the change in flux, we should be able to rule out which possibilities can't be true. So the first possibility is that our loop was sitting in a magnetic field that's pointing into the page. And now let's imagine that this magnetic field was increasing in strength, right? So if it was increasing in strength, that means that the flux would also be increasing over time. So the flux would be increasing into the page. So by Lenz's law, we would want to create an induced current with a magnetic field that points out of the page, right? Because we want to oppose that increase into the page. So that wouldn't make sense with what we know about our induced current creating a magnetic field into the page. So this possibility can't be true. So that only leaves one other possibility for us, which is that our magnetic field is pointing out of the page, but let's still see if that makes sense. So let's imagine that our field is pointing out of the page towards us, and the strength of that field is increasing with time. So we'll want to create a current to oppose that by Lenz's law, which is going to be in the opposite direction since the flux is increasing. And the opposite direction from out of the page will be into the page. And that makes sense with what we know about our induced magnetic field here, is that it's going to be pointing into the page. Okay, so then now we can conclude that the magnetic field that this loop must have been in the direction of out of the page or towards the observer. So B points out of page / towards observer. And that's the original magnetic field, right? I should put little subscript induced here on our induced one, just to avoid confusion. So there you have it. By using Lenz's law, we were able to figure out what the direction of the increasing magnetic field must have been for this loop, given that we knew the direction of the current.